Hello everyone. So today we have 2 to the power of 9 to the power of x all over 8 to the power of 3 also to the power of x equals to 1 over 4. So if we solve together, let's see solution. So we're going to represent 4 as 2 to the power of 2 and we'll represent 8 as 2 to the power of 3. So that the next line becomes 2 to the power of 9 to the power of x all over 2 to the power of 3, that is 8 to the power of 3 to the power of x is equals to 1 all over 2 to the power of 2. But a to the power of n over a to the power of m can be represented as a to the power of n minus m. When the bases are the same, we can subtract the powers. The common base is 2, and the power 9 to the power of x minus 3 times 3 to the power of x is equal to 1 all over 2 to the power of 2. And again, 1 all over a to the power of n also can be represented as a to the power of minus n. Please subscribe and give us a thumbs up if you have not subscribed. Thank you. So if we do this very well, the equation becomes 2 to the power of 9 to the power of x minus 3 times 3 to the power of x. This equals to 2 to the power of minus 2. Again, from a equals to n equals to a to the power of n equals to a to the power of m. When the bases are the same, the power can therefore be equated, that is n is equals to m. So we're going to apply it here. Common base of 2, so we equate the power, that is 9 to the power of x minus 3 times 3 to the power of x is equals to minus 2. And 9 can be written as 3 to the power of 2, also to the power of x, minus 3 times 3 to the power of x is equals to minus 2. So here we can decide to bring minus 2 to the left hand side, so that 3 to the power of x to the power of 2 from here minus 3 times 3 to the power of x plus 2 will all be equal to 0. And if we agree that 3 to the power of x will be represented with k, the next line will become k to the power of 2 minus 3 times k plus 2. This is all equal to 0. So if we factor this very equation, we can have k to the power of 2 minus 2k minus k plus 2 equal to 0. What is common here is k. What is left is k minus what is left is 2. And what is common here is minus 1. And what is left is k. And the other side is minus 2. It's all equal to 0. If we open up this bracket, we're going to get back the previous line and we're fine. So here, we're going to take the common terms. That's k minus 2. What is left is k minus 1, all equal to 0. So from here, case 1, k minus 2 equals to 0. And case 2, k minus 1 equals to 0. So that k will be equals to 2. And here, k will be equals to 1. But recall that k was represented with 3 to the power of x. So that 3 to the power of s will be equals to 2. And here, 3 to the power of s will be equals to 1. And 3 to the power of s will be equals to 3 to the power of 0. So that x is equals to 0. Here, x1 is equals to 0. And here, we're going to take natural log of both sides. That is log 3x is equals to log 2. So that x log 3 will therefore be equal to log 2. And if you divide both sides by the coefficient of x, which is log 3, it becomes over log 3 over log 3. So log 3 cancels out. What's left is x equals to log 2 over log 3, and can be written as s equals to log 2 base 3. So that x1 is equals to 0 and x2 is equals to log 2 base 3. Thank you for staying tuned. Please subscribe, give a thumbs up, and leave a comment. Bye bye.